I'm Matt Godbolt.
And I'm Ben Rady.
And this is Two's Complement, a programming podcast. Hey Ben.
Hey Matt.
How are you?
You should leave that in.
Oh no. All right. How are you doing? I will leave it in, won't I now? Because I'm too lazy to edit. Sorry, listener. You're going to have to listen to that. That's awful.
I'm doing good.
I'm glad to hear it.
Yeah.
I'm glad to hear it. Oh my gosh. Well, yesterday, you and I were chatting with a colleague, and he made a very astute observation.
He did.
About the way that we develop software, and in fact, the way the sort of group of individuals that we've surrounded ourselves with over the years, over like the last decade that we've been kind of vaguely hanging out at the same company, about the way that that we develop, or we at least approach software development. And so I thought, let's talk about that today.
Yeah, that sounds good. I'm trying to remember what his exact phrase was. I'm going to paraphrase him a little bit here, but it's something like, the previous companies that I had worked at, if someone came along and said, "Hey, I built a message queue," they would be instantly fired. And I think he was kind of talking about our both what's the opposite of reluctance? Not aptitude, not enjoyment. There's some...
It's eagerness, maybe?
Eagerness. Perfect word. Our eagerness to go and build solutions for problems that are problems that other people have attempted to solve, perhaps even in a similar way, but not similar enough for our tastes a lot of the time. And I know you have done this, and I have done this, and you could very easily categorize this as not invented here syndrome, and I don't.
Right.
I don't reject that
For
characterization at all. Like, that's
no,
very
I think that's
fair.
a character flaw that we all suffer
That's
from.
very fair that this is a little bit of not invented here, but I think that we do have some rational reasons for doing these things, and maybe we can take this episode to sort of explain some of those.
Absolutely.
Reasons.
So I think one of the motivating examples that we came up with was a package management system that our previous company had developed called Fig, which was effectively, before its time, a Conan or a Conda or a insert your like development package needs here system, which would allow you to describe your project's dependencies, go and grab them and unpack them and solve, like, well, this needs this version of that, and give you errors when they weren't. And of course, there are thousands of those around. I mean, most notably, your operating system almost certainly has a variant of some kind of package management system. So, you can have Debian packages, or you can have
Snap.
Snap. Well, nowadays you can have Snap. Obviously, this was like 12 odd years ago.
Yeah.
So I don't know that those things were necessarily around.
No.
Of course, nowadays people will do Docker builds and things like that.
Yeah.
But I'm certain that there were solutions. I mean, effectively, most, at least script languages, have their own homegrown solution. I mean, Python has had pip forever. And I think the overwhelming problem that we were trying to the problem that we were trying to solve here was that there is a community-based, at least at the time, sort of somewhat lackadaisical attitude towards the exact versions of packages that came down. And so you pip install, and at least back then, you just sort of said, give me the version of this. And it just installed that version with, if it needed other packages, it would bring them in, but it would make no effort to make sure that everything worked together well. Nor did it guarantee that if I were to then check in some code that it pip installed some stuff, that with my CI would get the same versions of that. And so we had this problem where floating versions would move around, and that was not a good look when you're trying to explain that, well, it worked on my machine, then we built it on CI, and then we deployed it to a trading system, and it did the wrong thing.
Right.
So that was the sort of motivation behind it, at least the beginnings of the motivation of it. And I think our colleague was like, no one else would do that. That's crazy talk. You would just make something else work well enough for you and get on with your life. And I think, the queue example, he said, that someone would get fired if you came up with a message queue. Whereas, again, we developed an internal message queue based off of like some of the papers that we'd read, but we didn't use anyone else's code for it. And again, that could be not invented here, but I don't know so from my point of view, I was doing a lot of native code at this company, and I would now retrospectively justify a lot of my decisions based on how hard it is to share code. It's not as straightforward as just like pip install or conda install nowadays of something. There's normally some kind of dance you have to do to make sure you get the right version of the code and its dependencies and get the source and check it out and build it and all that kind of stuff, which to a greater extent, actually, things like VC Package and Conan have now solved, but only fairly recently. But back then it was like, well, it's almost as much effort to download this package, work through its README of how its particular brand of Makefile or scon scripts or whatever to build the package that I want, and then find where it installs its headers to copy them to, oh, sorry, I'm just going to do it myself. So that's my retrospective justification. But you weren't in native land. How did this manifest for you?
Well, I've definitely had a few instances of this, some of which I would do over again, and some of which were, I would say, a mistake. The ones where I really feel like we did the right thing were probably more along the lines of avoiding unnecessary. They're a little smaller in scope than building like a whole package manager, right? It's more along the lines of avoiding pulling in some large tree of dependencies, right? To solve a particular problem than just like, you know what, I'm just going to write this myself, right? Or I'm going to use what the platform gives me, and I'm going to enhance that in some way. I'm going to add I'm going to build some additional code around that in some way. And like, I had an experience with this like very recently. We were talking about this using some AWS services that like almost did what I wanted. And I was like, I spent like a couple of days like digging through the documentation, trying to figure out how to get them to do exactly what I wanted. And, after a couple of days, I'm like, all right, I'm just going to build this myself. And I built a reasonable implementation in about a day and a half. Like I'm actually working on that a little bit today, but it's like a day or two, right? So I spent a couple of days reading documentation, couldn't figure out how to do what I wanted, and now I've spent a couple of days basically re-implementing that thing, right? The trade-offs of that decision are something that you could definitely debate on either side, right? Should I have kept trying to figure out how to get what I want through configuring the service? Should I have tried to build the minimal set of things? Like another way to approach this problem is, all right, this service has its capabilities. I'm going to change something upstream or downstream of that to accommodate what it's capable of doing, so I can use it as is and as designed. And that's going to make other parts of my system more complex, but I'll be able to reuse this thing. That's a completely reasonable way to do it. That's not what I did. What I did was I built the exact thing that I wanted. And it doesn't do anything else. It doesn't do all the things that service does. It only does what I need it to do. And it does it in exactly the way that I want it done. And it's very testable, right? And all of those properties for me are exactly what I want. And like I now have that code in my system, and I have to deploy that code, and I have to test that code, and I have to maintain that code, and I have to carry those costs. But in my mind, those costs are lower than the costs of either adding complexity to other parts of the system in order to accommodate the way that this service works out of the box, or continuing to bang my head against, can I ever get this to work, right?
Right. I mean, in particular, things like testability, when you're talking about something that's a service, if it doesn't provide a kind of run locally or a stubbed version, or it's not straightforward to do that, then you are definitely giving up some testability, or else you're spinning up things in the real world and integration testing things. Whereas if you make it yourself, you can put the points in where you need them, the test points.
Yeah, and it's exactly that. It's okay, if we use this service, we're going to forevermore have this future integration test cost, where the only way to be confident that we've we haven't broken something when we make changes to the system is to run very expensive and potentially unreliable integration tests. And we will pay those costs basically forever,
Right.
as long as this project runs. Whereas I can have a very fixed cost of writing a bit of code and testing it and using it the way that I want, building out all the stubs that I need. And then those tests will instead be unit tests that will run quickly and reliably. And yes, I do have the ongoing cost of maintaining that code if I need to change it. But that's also a bit of a feature in that, like, okay, I have something new that I need to be able to do. Oh, the service doesn't support that. That doesn't matter. I've built my own thing. I can change it however I like.
Right.
So, it's hard, and it's hard to quantify these things, and it's hard to measure them objectively and say, like, my decision was good and here's the spreadsheet that shows it. A lot of it is based on intuition about what future changes will come, and that's really hard to hard to make predictions, especially about
the future.
So it's a judgment call at the end of the day, but it's one that I definitely feel comfortable making.
And I think that's one of those experiential things that you just have to draw on your experience of, like, I have seen this before, or something that looks a bit like this before. In my experience, it would be worthwhile doing it this way, like choosing to write it myself, taking on that complexity with open eyes of the understanding of how much work that might actually pan out to be. But yeah, again, that sort of feeds into the not invented here kind of stuff. And, like, sometimes you have to ask yourself the question, am I answering this truthfully? Like, is this something that I do need, or is it cool to write it? And would I be excited about working on it? Which sometimes maybe that is enough to justify it, because, we're humans. We love what we do. We're lucky to have this job where we do actually enjoy what we do. And maybe motivating it and doing it yourself is enough of a cost. If it's a day or two, like you've done, right? That's fine. If it's a 6-month project, maybe we should talk.
Yeah, right. Exactly. And we were kind of talking about this yesterday, where I think you can too easily discount, and, engineers who are try to be hyper rational and, take their emotions out of everything. And I think discount the value of having somebody that wakes up every day emotionally invested and motivated in a project to make sure that it works and works correctly.
Right.
That's an extraordinarily powerful effect. And you shouldn't dismiss it because it's like, oh, well, why did you rebuild this thing when there's this off-the-shelf thing that does exactly that? It's like, well, if I use the off-the-shelf thing, I'm not going to give a fuck about it. I'm gonna have it do what it does, and I'm not really going to care too much if it's testable or if it's easy to maintain or if it works. It's just sort of this thing, and I don't really care, right? And there are lots of places where that's exactly what you want. They're like, I don't really want to care about this problem.
Right.
I'm not
this is
interested
not
in this problem. This
important or germane enough to my
solve.
product, to care, or yeah. I mean, I have a sort of counter to that. I'm working with an open source vendor library that I'm sort of mandated to use for a particular thing that I'm doing, and it doesn't quite work the way that I want to do it, and the underlying thing that it does, I could, like, I say reverse engineer. I have the source code, so it's not really reverse engineering, but it's not documented the sort of underlying thing that it's doing. But I could work it out and then write my own. But I have no wish, no desire to do that. That sounds like an awful lot of work to reproduce what this vendor is providing us. The scope of what the vendor's code does is much, much, much broader than what we need. So I'm picking up this giant library with all of these dependencies that it brings, only to get access a tiny part of the feature. So it definitely feels like the pendulum could swing back towards just wrap this tiny part of it. But instead, I decided to go in and go, like, the thing that I actually need it to do that it doesn't do, I'm going to do a surgical change to their open source project, fork it, and then we're going to use that ourselves. And now we can sort of take it out of the mix. And that was mainly for that testability and reproducibility reasons. There's like a binary underlying protocol that I had to either consume directly from a TCP stream or go home. And I'm like, I don't want to have to consume this. I want to write a test that doesn't need a TCP server in order to do its work. That seems silly. So, but I could have chosen to kind of roll my sleeves up and say, I will spend 2 months re-implementing this protocol. But I didn't make the call that way.
Yeah. But I mean, I definitely have also had instances where I've done this and regretted it.
Right.
It was not the right choice. One project in particular at PrevCo, which I know you were actually a user of, the monitoring system that we built.
Oh, yes.
We started out in that system using MongoDB as our database.
Right.
And we had some problems with Mongo, and that was it was like Mongo 1.0 or something. It was very early days. And, I don't even know if those problems are still a problem or whatever, but we definitely had some pretty significant problems. And so at one point, as a team, we were like, "F it, we're just going to build our own database." And that was a mistake.
I think if those words leave your mouth, you should seriously consider what you just said.
Yep. And we're like, it's fine. The whole point here is that we don't need a relational database. This is mostly for, the messages that we were basically, we needed a database to store messages that were coming off of a message queue. They weren't really relational in any way.
Right.
We chose Mongo because it was like a document database, and we thought it would be a good fit.
Right. It sounds it on paper, but
yeah, and I don't doubt that we needed some kind of non-relational, NoSQL document type database, whatever. We just should have tried something else after Mongo before immediately jumping to we're going to write our own database.
But presumably, in your defense, you had just been burned quite badly by whatever things you discovered in this nascent early version of Mongo.
Yes.
And so you were kind of like, you're on the rebound, as it were, from that, going like, well, I'll never date again. I'm just going to have to do this by myself.
Yes. Lonely me. I'm never going to find love.
So I should write my own database.
Yeah. And in fairness, it was one of those things, and we talked about this yesterday, where it's sort of like one of the advantages of doing this yourself is that you do set yourself on a path to incremental success, right? Like, I know if I just put in enough time and effort, eventually I will create a solution that will solve this problem.
Right.
I don't know how long it's going to take, but there's no chance that I'm going to basically wedge and have to start over from zero, right? Or the chances of that are very,
very low.
Right?
Unless you discover it's NP hard along the way, and that's why no one else can do it, right? But you can make forward progress at every step, and you can set yourself a goal. You can guess how long it's going to take you, and you'll still be wrong, but you will be able to get there. Whereas if you're reading the documentation of a system and you're playing around with the system, there is no guarantee that you won't discover towards the end, oh, it just doesn't do the thing I need it to do. Or if it does, it doesn't do it in the way that I need it, or it's not performant enough, or it, whatever.
Yeah.
That
some other hard constraint that basically devolves down to, well, I could fork this and do it myself, but at that point, I am just kind of like building my own thing, right?
Right.
So yeah, and in our case, like we had this situation where we had deployed the system, we were using it, it was being used in production, and Mongo was basically falling over. And we sort of had this thing of like, okay, we could try another database, but we might just be back where we are right now in 2 months. So let's write our own. Again, this was still a mistake.
Okay.
we should have tried.
I think you mean it was a learning opportunity that you took.
It was an opportunity for, yes. It was the classic example of good judgment comes from experience, and experience comes from bad judgment. But it is definitely not something that I would do over again.
Right.
But in fairness, we did eventually build a database that was a solution to our problem. It's just that the ongoing costs of that and the time that it took to really get it into a state where we were happy with it, like the trade-off just wasn't.
It wasn't the right.
Like we should have
trade-off.
We should have tried some other. We should have done honestly, if I were to do this over again, I would do more of a set-based approach where I would say, all right, we've got 4 people on this team. For the next 2 weeks, we're going to explore 4 different databases. So everybody pick one and go
that's an
try
interesting
it,
approach.
and share your results as you go along. There's no reason to wait to the end, but we need to parallelize this effort, and we need to try as many things as we can, and hopefully we'll find one that works. And if we don't find one after 2 weeks, then we'll do another 2-week. Or maybe we'll build in our own, or who knows, or maybe we'll fork one.
Yeah.
We'll take one and fork it.
You'll have some information there, information gathering.
Yes.
I think. Speaking as for myself, really. I find that stuff really hard to do. I get so invested so quickly into something, or I get very quickly like, this is rubbish, I'm not going to be able to use it kind of thing, and then I'll go away. So I 2 weeks sounds like a long time to do that, but I think you're right. That the approach is sound. going multiple ways at the same time, so that everyone can meet back up at the table and sort of say, well, I hit this snag, and someone else could say, oh, I hit that snag too. Maybe this is actually intractable. Maybe this thing can't be done the way that we want to do it in any reasonable database, and that might inform your decision to say, well, let's see if we can do it ourselves.
Yep. So, these kind of decisions that we make in this preference that we have, it's definitely not obviously the right thing to do. I think that I can pretty easily justify some of the decisions that I made. They've turned out pretty well. Some of them are maybe a little bit more borderline, and some of them, as we were just talking about, are clearly not the right thing.
Yep.
But it does have a number of benefits. It has this benefit we were talking about of you definitely tend to be more invested. You become an expert in the solution that you create in a way that I'm not going to say it's not possible for something that you pull off the shelf, but it's just, certainly for me personally, it's significantly more difficult. And I feel like most people who are think of themselves as software engineers, people who build software for a living, their brains just click in better when they have built something. It's the same reason that you, like in school, are like, we're going to implement this algorithm, right? And in the real world, you will never implement this algorithm. Please do not implement this algorithm. There are untold number of libraries that people much smarter than you have implemented this algorithm with all the different corner cases, and you should use their solutions and not your own. But just to make sure you actually understand how it works, we are going to implement this algorithm, right? And I think that effect is a very powerful effect. And so when you build these things for yourself, it's less likely you're going to get stuck in the sort of like, this is broken and I don't understand why. Right.
How well does that translate though for new members of the team? Because that works if it was you, literally oneself, building the project, or the people that were involved in that feature. But then to somebody coming onto the team who hasn't seen it before, you've got a sort of double problem of like, it's not a standard solution, so there's no chance in heck that they would have had any experience with it, and they have to learn it as if it was a new system now. So I don't know if that's
No, I mean it definitely is a concern. But one of the things that I would say is, so imagine that you instead chose to use some open source tool, right? And that tool is like a really important part of your system, right? Like it's critical. You depend on it, right? Immediately you start asking questions like, can we hire the maintainer?
Right.
Are they available? And if you build it yourself, you've done that by default. That
is true.
Right? You have the person right there that you're working with every day that knows the system top to bottom, and you can just ask them questions. And so as a new person on the team, you have that sort of baked in expert. Now, that expert might have a lot of constraints on their time and might not be able to share, and that's when you start, writing a bunch of documentation maybe, and then you're wondering like, why am I doing this? So there's definitely reasons or situations in which that can fall down. But I do think one of the strengths of that is that you have that person that is like, can just off the top of their head be like, oh yeah, you need to go look at this file. This is where that's controlled, and you can configure it like this, or these are your options. And if you try that, that won't work.
Right.
Because they wrote the code.
They
right?
know it, yeah. So I guess you have a domain expert who is also, again, invested, we hope, in the product and the project, and is hopefully, if you've employed the right kind of people, is excited to tell people about it, and effusive, and rather than like, oh, it's just Postgres just does it that way. Sorry, we can't do anything about it. It's just the way it is, kind of thing.
Yeah. And I mean, there are definitely dysfunctional forms of that where people will build these systems and then like be very reluctant to share their knowledge or write documentation.
The job
or whatever.
security dysfunction of like, I'm just the expert in blah now. Everyone needs blah, so I'm set for life now.
Yes, and there's less pathological forms of that too, where it's just like, I'm just really busy. I can't do this, right? I have a lot of other responsibilities. I can't spend all my time explaining to people how the system works.
Right.
Like, I wrote some docs. Maybe you should read the docs.
Well, that's another thing as well. Like, obviously you can help yourself by documenting stuff, but like certainly typically in organizations that I've been involved in, documentation is at best out of date and at worst actively harmfully wrong.
Right.
Which is,
Yes.
I mean, I believe that to be the natural state of documentation, which is why I heavily discount it myself. So that's why I don't tend to read other people's documentation, which is sometimes is problematic, because they'll say, "Well, did you read the docs?" I'm like, "No, because the docs are just wrong by they're definitionally wrong as far as I can tell." And they're like, "No, these ones are actually up to date." And like, oh, now I feel terrible. I feel like a bad person.
I'm mostly with you there. The best docs are the code. Like,
right,
you know, it's like you should have a README that explains some basic concepts, and if it's any more than about 3 or 4 pages or 3 or 4 screens worth, what's a page?
I don't know,
even knows
page,
what a page is anymore. Yeah, 3 or 4 screens worth of text, like there's probably some lies in there.
Yeah. I will say I've had some good
you know,
success with executable documentation where I've used like PyDoc style tests, and it's like, yeah, you know, my documentation is up to date because at least the bits that mention code, they still work and they pass the test, which is a good way. But anyway, we digress.
Yeah,
we digress.
Yeah.
So one thing that came up when we were chatting yesterday was the sort of like there are different mentalities towards making reusable components. So what we're talking about here are reusable components. We've mentioned sort of like system level things really in most of this type of stuff. You know, you mentioned a database, which feels like a system, even though it could be implemented as more of a library. But the vendor solution I was talking about was a big library, but it's an ecosystem of lots of libraries, and they do lots of things. There's a huge amount of things that they do that I don't need them to do, which gives me complexity I don't want. But there's definitely something to be said for the kind of manicured, very well developed and well thought about domain expert library. When you actually pick up a library that's like that, and you're like, I know I can trust the folks behind this to have thought about everything extremely thoroughly, and so I don't need to know the product well enough. Maybe I don't have these particular needs that I would develop it myself, but I'm actually almost, I guess this is like, one could argue this is the way you might choose to vote, right? I vote not because I want to choose everything myself, but I'm picking somebody who is smarter than me to make the decisions, like the delegation type thing, delegation theory of like why you vote. And maybe I'm like, well, I need a library that does X. I don't have a strong belief about how X should be done, so I'm going to pick someone else's X because it will come with their sensible choices for everything about X that are on the periphery.
Yeah.
And so that's maybe one argument against the inventing it yourself, where you have to like make hundreds of somewhat arbitrary decisions for things you don't necessarily care about, and you aren't maybe not as invested in coming up with the right balance of like, should we use threading or thread pools or different processes, or I don't know, but someone else has thought about this, and maybe it's configurable, maybe it isn't. So there's a value there.
Exactly.
A value that's...
No, absolutely. And I think the thing to consider with making those choices is very similar to what we've talked about with programming languages on a different episode of the podcast, which is, you know, we said before, it's like when you start using a programming language, you implicitly have to adopt the values and principles of the community behind that language.
Yes.
And those are almost more important than the language features. If that community values testability, you will be forced to value testability by using the platform and the APIs and the language and all the things that are built around it. If they value thread safety, if they value terse syntax, if they value a functional style, whatever it is, you're either going to be fighting against the current the whole time you're using it, or you're going to have to adopt those ideas. And I think that you get that same effect sort of in a slightly smaller form when you're using somebody's library. And I think that you've experienced this in your day job with this vendor library that you're using, where the ideas and principles that they put into that library are not necessarily the ones that you would choose. And there's a cost, there's a tension that is created because of that. And now you're sort of forced to make a choice of like, well, I don't really want to care about this problem, but man, I wouldn't have solved it this way if I did it. So that's creating tension. And the sort of sweet spot, the wonderful situation that we're all aiming for, is when you can successfully delegate the creation of a solution to somebody, and their values and principles align enough with your values and principles to where you can be like, yeah, I probably would have done it in a very similar way. This library is great.
Yes.
Right? but that's sort of the trade-off. And I think, like that's obviously like a little bit of a gradient, right? It's not a binary thing, pun intended. But the choices that I think we tend to make would lean us a little bit more toward the side of like, you didn't solve this the way that I would want to solve it, so I'm just not going to use it, right?
Yeah. And I mean, that's definitely a symptom, and I wonder sometimes whether or not, am I just using this library wrong? Have I come at it from the wrong axis? And then that's when, if you know somebody who has used a library or a feature before, and they go, oh, yeah, you're thinking about the problem wrong. You can solve the thing that you need to be solved, but you're thinking about it wrong. If you rephrase it this way, then it just falls naturally out of this library. You're like, brilliant, I needed that. I was going against the grain, not because I fundamentally disagree with some way that the system is designed to be used or whatever, but because I didn't know and I couldn't find out how to rephrase my my problem in the right way. But sometimes you're like, I am going against the grain and I'm just fighting and fighting and fighting and fighting because it's not actually possible to use it the way that I want it to be used, and there is no better solution. It's just like, well, sorry, it's not really designed to do the thing that you want it to do, which is a bit more like my most recent experiences. They're like, well, sorry, that's just not how it works. And like, well, oh, okay, I guess I'm stuck then, right? I've made I can't make another choice in this particular example, but and it's not wrong, right? Everyone has different values, of course. That's they're not necessarily wrong. It's just not the way that one would choose to do it.
Absolutely. I mean, everything is a bit of a portfolio optimization where you're choosing from different trade-offs, and the things that you value are going to be a function of your strengths and your weaknesses, and it's going to be different for everybody. So yeah. But one of the things on that I have done and I have also seen you do is you will ask people that you know and trust, perhaps in a Discord channel or a Slack channel, hey, does anyone have a good library for X? And what you're asking when you ask that question is not, can you Google this for me?
Right.
What you're asking is, hey, people that I know and trust and have similar, but not necessarily even the same sort of strengths, weaknesses, values, principles that I have, but I know what yours are. And if you tell me that library X worked for you to solve a problem, I will be able to interpolate whether it will work for me, right? So like, I know that you, for example, value performance and native fast execution, and therefore if you say, hey, this is a great library for X, I can be like, well, if my concerns are, is it going to be fast enough? The answer will be yes.
Right. Right.
Or I can ask you and say like, hey, was it fast enough? And you were like, absolutely. And then I'll be like, yeah.
And I know if I ask you about something, then it almost certainly will be testable.
Right,
or mockable,
exactly.
Or have some kind of affordance to testing.
Right, and you'll be able to pre-populate and say like, yeah, it's great for this, but watch out for this thing, and this will burn you, and this is a problem. But otherwise, it's cool, right? Like so it's like when we ask those kinds of questions to the people that we've worked with before, it's not about like, hey, can you do a survey of all the possible tools for this for me? It's like, can you relate your successful experience with this thing,
or even
so that I have confidence that it'll work for me.
Or even like say, I don't have a good suggestion, but I have tried X and it was a catastrophe for these reasons, which sometimes is as valuable. In fact, it's more valuable, right? Don't go down these blind alleys. They look like they will bear fruit, but they almost certainly won't. Now, of course, sometimes again, that person has done things wrong. There have been times before now where I've told people, no, that system doesn't work that way, and then they've turned around and said, well, actually, I took a look and it does. And you're like, oh, well, today I learned.
Yeah, that's sort of the bit about if you ask an old graybeard engineer if something doesn't work, and they say, yeah, no, it doesn't work. You can sometimes discount what they say, like that's fine. But if they say that it works, it almost certainly works, right? Like unless they're just straight up lying to you.
Yeah, it's hard to misinterpret success. Whereas defeat can sometimes be, well, again, if you rotate it 90 degrees, it fits in through just perfectly, actually. Just rephrase your problem.
Exactly.
Well, I mean, it was an interesting discussion yesterday, and it has been an interesting discussion today. I certainly had never really thought about it. It was for you and I think it was such a sharp observation for us both. It took us kind of by surprise, that it was just
Oh,
offhand
definitely.
handed to us as like, hey, I've noticed this thing about you, Matt
Yeah.
and Ben, and the folks that we've worked with from the previous company, that you all have this really low threshold for reinventing things or making things yourself. You don't seem to be dissuaded by how difficult it might be. And it was presented to us as almost a neutral observation. I don't think it was meant as either a slight or a blowing smoke towards us.
No.
It was like, hey, I've just noticed this really unusual thing. I've never seen it at companies I've been at before. And so it makes for a perfect conversation topic for a podcast. And I wonder what other people listening feel. So it would be interested to hear what observations our listener has about when you should build yourself, when you should investigate, and when you should just, I don't know what the other solutions are, whether you should just go home.
Yeah.
Which seems like a perfect time to go home ourselves and call it a day.
Sounds good.
All right, I will see you another time.
Yep.
Bye for now.
Bye.
You've been listening to Two's Complement, a programming podcast by Ben Rady and Matt Godbolt. Find the show transcript and notes at www.twoscomplement.org. Contact us on Mastodon. We are at twoscomplement@hachyderm.io. Our theme music is by Inverse Phase. Find out more at inversephase.com.